In this video, we will be looking at the sum of an infinite series. Let's remind ourselves what the difference is between a sequence and a series. If we have the numbers a half, a quarter, an eighth, a 16th, etc., that is an infinite sequence. When we add them up, we get a half plus a quarter plus an eighth plus a 16th, and we continually add them up to find a value s. We get an infinite series. But what is the sum of the series a half plus a quarter plus an eighth plus a 16th? Let's look at it pictorially. If we draw ourselves a unit square and then cut it in half, we get a half. Then if we cut the remaining half in half, we get a quarter. If we then cut the remaining quarter in half, we get an eighth. Then we cut the remaining eighth in half, we get a 16th. Then we cut the remaining 16th in half, we get a 32th. Then a 64th. Then a 128, then a 256. We can keep doing that infinitely, but we will never go out of the unit square. So the sum of our series, a half plus a quarter plus an eighth plus a 16th, going on forever, is equal to 1. We can prove that algebraically, so let's write our sum down using sigma notation. So we would get the sum of 1 over 2 to the power of n is equal to a half plus a quarter plus an eighth plus a 16th plus, and that would equal 1. Let's call the sum s, so we get s is equal to a half plus a quarter plus an eighth plus a 16th plus all the way to infinity. Now I'm going to divide the sum by 2. So I get s over 2 is equal to a quarter plus an eighth plus a 16th plus 1 over 32 plus all the way to infinity. I'm now going to do s minus s2, so I would get s minus s over 2 is equal to a half. Therefore, s over 2 is equal to a half. Therefore, s is equal to 1. So the sum of my infinite series, a half, a quarter, an eighth, plus a 16th, is equal to 1. So the series, a half, plus a quarter, plus an eighth, plus a 16th, plus all the way to infinity, is equal to 1 and is an example of an infinite series. Whereas if I've got the series 1 plus 2 plus 4 plus 8 plus, and I just keep adding and adding, that will just keep getting larger and larger and larger and we'll end up at infinity. And that is an example of a divergent series. It just gets larger and larger and larger and tends to infinity the more and more terms you add. The infinite series we say converges. In the formula booklet under section 1.8, we're given the formula for the sum of an infinite geometric sequence. This only works for geometric sequences, and the sum to infinity is equal to u1, remember, which is the first term, divided by 1 minus r, which is the common ratio, and the common ratio must be between -1 and 1, but it can't actually be -1 or 1. Now let's go through a few examples. Question 1. Evaluate a quarter plus a 16th plus 1 over 64 plus 1 over 256. First, let's find all our relevant information. So we know that u1 is equal to a quarter. We need to find r, and r is equal to u to the n plus 1 over u to the n, which is equal to 1 over 16 divided by 1 over a quarter. So r is equal to 1 over 16 times 4 over 1, which is 4 over 16, which equals 1 quarter. Now we can use formula. Sum to infinity is equal to u1 over 1 minus r. So the sum to infinity is equal to 1 quarter over 1 minus a quarter. So the sum to infinity is equal to 1 quarter divided by 3 quarters. Therefore, we get 1 quarter times 4 over 3, which is equal to 1/3. Question 2. Evaluate the series 20 times a half to the power of r between r equals 0 and r equals infinity. The first thing you should do is write down the first 5 terms. So when r is 0, a half to the power of 0 is 1, so the 20 times 1 is 20. The second term, a half times the power of 1 is a half, times 20 is 10. When r is 2, a half to the power of 2 is a quarter times 20 is 5, so the fourth one will be 2.5, and the fifth one will be 1.25. So that's the first 5 terms. Now we need to find r, so r is equal to u to the n plus 1 divided by u to the n. We can take any 2 terms, so we'll take 10 divided by 20, which is a half. So r is equal to a half. Now we can use the sum to infinity formula given in the formula booklet. So s, the sum to infinity, is equal to u1 over 1 minus r, which is equal to, u1 is 20 over 1 minus r, which is a half, which is equal to 20 divided by a half, which is equal to 40. So the sum to infinity of this series 20 times a half to the power of r is equal to 40.